So today we're going to talk about solving quadratics by completing the square. And we've solved quadratics in the past. Before we used factoring, so we would factor some long quadratic and we'd get something like x minus 7 times x plus, or x minus 6 times x plus 7. And it was always set equal to 0 so that we could solve, and we set each piece equal to 0. And eventually I got x equals 6, x equals negative 7. And that was really fine when they factored nicely. But if they didn't factor nicely, we said, oh, they're prime. I'm done. They're prime. And, that's true. Some of them can't be factored. They're prime. But it doesn't mean that they don't have an answer and that we can't find what x equals. So that's where solving by completing the square will come into play. And also, we'll talk at a later date about solving with the quadratic equation. But for solving by completing the square, it's easy if we start with an example. So we'll start here. And our first step is going to be to subtract the starting c from both sides. Okay, so if we did that, we would get, no, that was a bad line. We would get x squared minus 6x equal to 7. Okay, and then I can't factor this yet because I don't have a c, so we're going to get a new c. And my new c, I'm going to add it to both sides, but I need to know what my new c is going to be first before I can add just a random number. And the idea is that we're going to have squares, that this will factor very nicely into squares and we will be done. So the formula for c is going to be b over 2 squared. Okay? So I'm going to look at my equation. I'm going to say b is negative 6. So I'm going to do negative 6 over 2 squared. So that's negative 3 squared, which is 9. So I'm going to do plus 9 on both sides. Okay? When I factored this, this now factors really nicely. It's x minus 3, x minus 3. And this over here, 7 and 9, gives me 16. Well, I have this repeated term, which I can express as x minus 3 quantity squared equals 16. And this is where knowing what your squares are is going to come in really, really handy, because now I can square root both sides. The square root of something squared is just what's in the parentheses, so x minus 3. And the square root of 16 we know to be 4. And it's not just 4, it could be plus or minus 4, right? Because we saw when we squared a negative, it gave us a positive. So if I took negative 4 squared, it would give me 16, but also positive 4 squared would give me 16. So now I have a positive and negative, so I can set x minus 3 equal to the positive 4 and to the negative 4. Okay, and then I can solve by adding 3 to both sides. Over here, I'll get x equals 7. And over here, I'll get the x equals negative 1. So that's my solution set, x equals 7, comma, negative 1. Okay? So let's go ahead and practice just finding c values for a little bit. Okay, so maybe we start with x squared plus 26x, and I want to 26x, sorry. And I want to find what my new c would be. So again, we look at that formula, c equals b over 2 squared. And my b value is always that second one. So if you need to label across the top, I know I had some kids do that in the past. So I have a, b, and c. So b is 26. I'm going to plug that straight into my formula. 26 over 2 quantity squared. 26 over 2 gives me 13. 13 squared is 169. Okay, And again, having these squares memorized makes this really, really fast. So that c I want this time is 169. Try this next one on your own. If we have x squared plus 17x plus c. Well, hopefully you plugged it into your formula and you had 17 over 2 quantity squared. And you may have divided 17 over 2 into a decimal. You don't have to, though. You can leave it as a fraction. So you could have done 289 over 4 and left it just like that. In fact, that'll make it a little bit easier to plug in and do your do the process of completing the square. So applying that, when we find that c, we can apply it. Let's see what that looks like. So we'll go back to the solving the full problem. Let's start with x squared plus 6x minus 16 equals 0. So this is a typical problem you might find in a classwork. And remember that first step is to do what? Good, move the starting c to the other side. So I think in the first example we subtracted. This time we're going to add. It's just whatever sign we have. So we're going to move it to the other side. So we have x squared plus 6x equal to 16. Now I want to find my new c, just like we were doing in the examples. So I'm going to do b over 2 quantity squared. That's 3 squared, or 9. So I'm going to add 9 to both sides. Over here, that gives me a nice x plus 3, x plus 3. Over here, that gives me 25. I'm going to express my repeated term as a square. And if I look at that they're both squares of something. So I can take the square roots. That gives me x plus 3 equals plus or minus 5. And then I can do my two cases. X plus 3 equals positive 5. And x plus 3 equals negative 5. And I can solve from there. Okay, so I would get negative 8 and 2 as my solution set. Okay, I'm going to have you try this one on your own. So we'll do x squared minus 8x minus 1 equal to 8. Okay, so go ahead and work through it on your own and let's see what we get. So we should have gotten that my solution set is 9 and negative 1. And how I got that, I of course added my old c to both sides so that I got a 9 over here. I found my new c to be 16. I added that to both sides. When I factored, I got x minus 4 squared and 25. Took the square roots. So I got x minus 4 equals plus or minus 5. Instead of setting up two equations, I went ahead and added this 4 over, and I said 4 plus or minus 5 is equal to x. So that does include both solutions because I have that plus or minus hanging out still. And I said 4 plus 5 is 9, 4 minus 5 is negative 1. So you can write it either way. It's just however you will think best using it. Okay, and that is completing the square.